Today, we're going to learn about Group 1 of the periodic table, also known as the alkali metals. This is an important topic because Group 1 gives us a great example of how the position of an element in the periodic table can help us predict its properties and reactions. Let's begin. Group 1 is the first column on the left-hand side of the periodic table. The Group 1 elements are lithium, sodium, potassium, rubidium, cesium, and francium. At GCSE, you'll mainly be expected to know about lithium, sodium, and potassium. You may notice that hydrogen is positioned above Group 1. However, hydrogen is not an alkali metal. The alkali metals are the metallic elements in Group 1. So, what makes all these elements part of the same group? The answer is their electron arrangement. Elements in the same group have the same number of electrons in their outer shell. Every Group 1 element has one electron in its outer shell. For example, lithium has an electron arrangement of 2, 1. Sodium has an electron arrangement of 2, 8, 1. And potassium has an electron arrangement of 2, 8, 8, 1. Look at the last number in each arrangement. It's always 1. That single outer electron is the key to understanding the chemistry of Group 1. Group 1 atoms tend to lose this outer electron when they react. When an atom loses one negatively charged electron, it forms an ion with a 1+ charge. So, lithium forms a lithium 1+ ion. Sodium forms a sodium 1+ ion. And potassium forms a potassium 1+ ion. This is why Group 1 elements form 1+ ions. And because all Group 1 elements have one outer electron, they have similar chemical properties. Now let's look at their physical properties. Group 1 elements are metals, but they are quite different from many of the metals you're probably familiar with. They are soft, have relatively low melting points, and the lighter Group 1 metals have relatively low densities. Lithium, sodium, and potassium are soft enough to be cut with a knife. When freshly cut, their surfaces are shiny. However, they quickly become dull because they react with oxygen in the air. Another important property is their melting point. As you move down Group 1, the melting point generally decreases. So the elements become easier to melt. Now let's look at their most important chemical reaction. Group 1 metals react with water. This reaction produces a metal hydroxide and hydrogen gas. So the general word equation is Group 1 metal plus water produces metal hydroxide plus hydrogen. The reaction also releases energy, so it is an exothermic reaction. Let's look at what happens with lithium, sodium, and potassium. First, lithium. When a small piece of lithium is placed on water, it floats on the surface. It moves around slowly and produces bubbles of hydrogen gas. The lithium gradually gets smaller and eventually disappears. The reaction is relatively gentle compared with the other Group 1 metals. The balanced equation is 2 lithium plus 2 water produces 2 lithium hydroxide plus hydrogen. Now let's move to sodium. Sodium is more reactive than lithium. When sodium is placed in water, it floats on the surface and moves around rapidly. It produces bubbles of hydrogen gas. The reaction releases enough heat to melt the sodium, so it forms a small ball. The sodium continues moving around on the surface and eventually disappears. The balanced equation is 2 sodium plus 2 water produces 2 sodium hydroxide plus hydrogen. Now let's look at potassium. Potassium is more reactive than sodium. When potassium is placed in water, the reaction is much more vigorous. The potassium moves rapidly across the surface and produces hydrogen gas very quickly. The heat released can ignite the hydrogen, producing a flame. The balanced equation is 2 potassium plus 2 water produces 2 potassium hydroxide plus hydrogen. So, what have we observed? Lithium reacts relatively gently. Sodium reacts more vigorously, and potassium reacts even more vigorously. This shows us an important trend. Reactivity increases as you go down group 1. So potassium is more reactive than sodium, and sodium is more reactive than lithium. But why? This is one of the most important explanations to understand for your GCSE exam. Remember, group 1 metals react by losing their outer electron. Therefore, the easier it is for the atom to lose that electron, the more reactive the metal will be. Let's compare lithium, sodium, and potassium. Lithium has 2 electron shells, sodium has 3, potassium has 4. As we move down the group, the outer electron is further away from the nucleus. There are also more inner electron shells between the nucleus and the outer electron. These inner electrons reduce the attraction between the positive nucleus and the negative outer electron. This effect is called electron shielding. So, as we move down group 1, 2 important things happen. The outer electron gets further from the nucleus, and electron shielding increases. Both of these effects make the attraction between the nucleus and the outer electron weaker. Therefore, the outer electron is easier to remove. And because group 1 metals react by losing this electron, their reactivity increases down the group. So, if an exam asks you, explain why group 1 elements become more reactive down the group, you should explain it like this. As you go down the group, the outer electron is further from the nucleus and there is more electron shielding. Therefore, the attraction between the nucleus and the outer electron decreases. The outer electron is easier to lose. Therefore, the reactivity increases. That's the reasoning you need to understand rather than simply memorizing the trend. Now let's look at another important trend. The melting point generally decreases as you go down group 1. So remember, reactivity increases down the group, but melting point generally decreases down the group. These are 2 separate trends. Now let's return to the reaction with water. Why are these metals called alkali metals? When a group 1 metal reacts with water, it produces a metal hydroxide. For example, sodium produces sodium hydroxide. Sodium hydroxide dissolves in water and produces an alkaline solution. An alkaline solution has a pH greater than 7. This is where the name alkali metals comes from. Let's look at the reaction again. Sodium reacts with water to form sodium hydroxide and hydrogen. The balanced equation is 2 sodium plus 2 water produces 2 sodium hydroxide plus hydrogen. Notice that hydrogen is a gas. That's why we see fizzing during the reaction. You can also test for the hydrogen gas using the standard hydrogen test. Hydrogen produces a squeaky pop when a lighted splint is placed near the gas. Now let's connect this reaction to the electron arrangement. Sodium has 1 electron in its outer shell. During the reaction, sodium loses this electron and forms a sodium 1+ ion. The water molecules are involved in producing hydrogen gas and sodium hydroxide. The exact chemical details are beyond what you need to focus on here. For GCSE, make sure you know the reactants, products, observations, and the trend in reactivity. Let's compare the 3 main group 1 metals one final time. Lithium reacts with water relatively slowly. It floats, moves across the surface, fizzes, and gradually disappears. Sodium reacts more vigorously. It floats, moves rapidly, fizzes, melts into a ball, and eventually disappears. Potassium reacts even more vigorously. It moves rapidly, produces lots of fizzing, and the hydrogen produced can ignite. So the reactions become increasingly vigorous as we move down the group. Lithium is less reactive than sodium. Sodium is less reactive than potassium. And this gives us our key group 1 trend. Reactivity increases down the group. There is also an important safety point. Group 1 metals, especially the more reactive ones, can react dangerously with water. These reactions should only be carried out as controlled demonstrations by a trained teacher using appropriate safety equipment. For your GCSE exam, you need to be able to describe what happens and explain the trend. Let's finish with a quick check. What is the name given to the elements in Group 1? They are called alkali metals. How many electrons do they have in their outer shell? 1. What charge do their ions have? 1 plus. What happens to reactivity as you move down Group 1? It increases. Why does it increase? Because the outer electron becomes further from the nucleus, and electron shielding increases. This weakens the attraction between the nucleus and the outer electron, making it easier to lose. What happens when a Group 1 metal reacts with water? It produces a metal hydroxide and hydrogen gas. And what type of reaction is it? It is exothermic because energy is released. Finally, what happens to the melting point as you move down Group 1? It generally decreases. Thank you for watching. If you found this video helpful, please like, subscribe, and share it with your friends. Your support really helps the channel and allows me to create more chemistry lessons like this. If you have any questions, feel free to leave them in the comments below, and I'll do my best to help. Thanks again for watching, take care, and I'll see you in the next video. Goodbye.